The moon has been staring at Earth with the exact same face for 4 billion years, and while you've never seen its entire far side from your backyard, tiny wobbles called librations mean we actually get to peek at about 59% of its surface over time. Here's the setup. The moon orbits Earth once every 27 days, and it also rotates on its own axis once every 27 days. That is not a coincidence. This perfect match is called tidal locking, and the culprit is gravity, specifically Earth's gravity pulling unevenly on the moon's own body. Imagine stretching a rubber ball. Earth's gravity tugs harder on the near side of the moon than the far side, creating a tiny but real elongation like a football instead of a perfect sphere. Now, here is the key. If that elongated bulge is ever tilted away from pointing straight at Earth, gravity yanks it back, like a dog on a leash. Early in the solar system, the moon spun much faster, like a wobbly top. Every time that bulge got out of alignment, Earth's gravity applied a tiny braking torque. Over millions of years, the spin slowed and slowed, until finally the spin rate hit exactly 1 rotation per orbit, and the braking torque vanished. The moon locked into place like a key turning until it clicks. Here's a vivid way to feel this. Tie a ball on a string and spin around holding it. The ball always faces outward. It rotates once per orbit of you. No magic, just geometry. And tidal locking is everywhere in the solar system. Pluto and its moon Charon are mutually locked. They both show each other the same face, like two dancers frozen mid-waltz. Here's the payoff. Earth is also being slowly tidally braked by the moon. Our day is lengthening by 1.4 milliseconds every century. In the far future, Earth's day could stretch to match the lunar month, and the moon would hang frozen over one spot on Earth forever.